Hello there, welcome to Simon's Shed. Today we're doing a bit of a product review, and the product is DCC Concepts Cobalt Digital point motors. So it's not going to be a complete sort of how-to, because I've already done how to control points via DCC, so look up that search for that on the channel if you're interested in that. I used SEEP point motors connected to an ADS8 decoder board, which is an 8-way decoder board, which is also from DCC Concepts. So why, if I've done that, do I need to be looking at DCC Concepts Cobalt Digital point motor? Let me explain. So on the layout we've got 8 points, and I think you can pretty much see all of them in that shot. So I've got SEEP point motors, and they do two things. The first one is the obvious one, which is actually flicking the point blades over and changing the direction of the point. And as you can probably hear, it does that very reliably. In fact, 100% reliably up until last week, when the one there that leads into those two sidings would only throw one way. So thought I need to replace that. Now the second thing I use this SEEP point motors for is changing the frog, powering the frog. And 6 of the points, I would say sort of 95% reliable using that method. However, 2 of them, again that one there and the one on the inner loop there, just don't seem to work. They just don't seem to power the frog at all. So I'll give you a closer look at a point and explain what I mean. So just a very quick explanation, I'm sure most of you know this, but with electro frog points, you're relying on the contact between the rail and this bit of metal here when the point is thrown like that to power the frog, and that's not very reliable at all, I found, especially in N-gauge. So what I've done is soldered a wire here. It's sort of painted grey, but it's between this V here. It's sort of disguised, so you might not be able to see it, but that goes down under the baseboard to the SEEP point motor, and I think it's that one which powers the frog. So what happens is you've got a contact here, a gap and a contact there, and on the bit of metal that throws you can see that washer there, which is making contact once it goes across to there. So it's a mechanical switch, it's relying on that contact with that washer and that strip of metal there, and it's not always reliable, especially if you don't get the point exactly lined up, the point motor exactly lined up in the right place. It's not reliable at all. It's very difficult to get it lined up, and it sort of seems to jump out of alignment very easily. And even if you do get it lined up, you still sometimes get the occasional failure, which is usually cured by just flicking the point back and forth a few times, but still a little bit annoying nevertheless. So let's open it up and take a look. You get a little bit of instructions, which is not the installation instructions. You need to go on their website and download the full installation instructions. There's really detailed info on there, so definitely do that. You get a whole bag of screws and the arm to actually throw the points, which you can't see very clearly there, but we'll get everything out and figure out how on earth all this fits together in a moment. And obviously you get the actual point motor with the moving part there, and little pushy springy clips here, which means you can put the wires in without even doing any soldering. So with the seep ones, you've got 6 wires to solder onto there, and that's to do the frog and the point switching. Whereas it looks like with this one, we've got 2 here which take DCC. Remember, this is the digital version of the Cobalt. There is an analog version, sort of DC version, but if you do that, then you'd need a separate DCC decoder board, just like with this. The benefit of this digital one is it's all in one unit, so you put your 2 DCC wires in the first 2 holes, and you put your frog wire, which is clearly labelled there, in the 3rd hole, and that's it. 3 wires. So plus points for no soldering, and plus points for simplicity of wiring. I think what we should do now is do a bit of a sort of Simon Shed wiring diagram and show you how it all fits together. Okay, it's a real Simon Shed special wiring diagram. DCC controller, you got your DCC bus, droppers to whatever track you've got along the way, and you've got the Cobalt here. All you do is take a couple of wires off your DCC bus into the first 2 connectors, and the 3rd one, the frog wire, you bring up to the V of the point. Obviously that's not to scale. I haven't actually got a real point to show you, but you get the idea. That really is about as simple as it gets if you're going to wire up DCC controlled points that also power the frog. Okay, I have read the instructions, which is always useful, and I now know what I'm doing. This is everything you get if you buy a single one. You can buy other kits that have got like templates for drilling the holes and sort of ballast coloured stickers to cover up the holes and things like that, so worth looking into if you are doing a lot of these. But for now we will manage with just the single kit. So the top here you've got 4 slots. So my hand is the baseboard. It'll screw to the baseboard like that, and you can see this will move across. This is the wire that actually flicks the point. It goes into the little hole at the top, and this I've now figured out. This goes onto there, and what that does is, as you slide it down, it changes the point, the fulcrum if you will, at which the thing moves, so you can get more movement for O gauge and bigger gauges, or less movement for N gauge, which is what we want in this case. The 5 screws here are for the 4 slots, and there's a spare one, which is always good to see. The tiny little screw you just loosely screw into that hole there, and that holds the bar on, just so that this doesn't fall out like that. So that's how it all fits together. So yeah, that just goes in there. So that's the wrong screwdriver. So that it's just touching there, a bit more, but not so that it's tight, otherwise it won't work. So that's it assembled. I think since it's so easy to put the wires in, I think we'll give it a test and show you how to assign it an address in DCC. Let's give that a try. Okay, I'll just quickly show you how easy it is to program the address in. So we've got the DCC controller and 2 wires literally just going straight from the controller into the 2 DCC line ports there, and the blue tack is just so that you can see the actuator moving a bit better. So all you do is, on here there's a tiny little switch. Whoops, you carefully flick that across. That puts it into learning mode, and then you just whatever your controller is, you just do whatever you need to do as if it was already set up. So in this case, just type in the number and press the direction. Then you flick the switch back carefully, and that's it. So there you see, it's pretty quiet and very smooth and very different to the sort of solenoid type of motor. So yeah, that's how you do it. So next we need to mount it on the baseboard, and to do that, as I say, you can get this accessory pack which has a template to mark all the holes out, and it also includes double-sided foam pads that you can use to stick the Cobalt to the bottom of the baseboard. I haven't got that, but I have got some double-sided foam pads, and my method of mounting it is use the sticky pads, stick it on, give it a try and adjust as necessary. Once it's all working perfectly, I'm just going to draw around these holes, drill the holes, and then it'll be secured by the screws as well as the sticky pad, so it's not going to go anywhere. Okay, so I've not screwed it into the baseboard yet, but I've stuck it on, lined it up, and we have a problem. It does work. However, when I remove this piece of paper, remember it's powering the frog, what happens is it short circuits the whole system, because all points, certainly all sort of off the peg points, have springs in them. So as the Cobalt underneath is moving across and changing polarity, the spring is holding the rail against there, and it's changed polarity and caused a short circuit. So unless the Cobalt happens to change polarity exactly the moment when the spring flicks over, which is like a 1 millisecond window, it's going to cause a short circuit. However, there is a solution, and the solution has the benefit of, as well as solving the problem, it also makes the point operation look more realistic. It is quite a drastic solution, and it is simply to remove the spring on the point. So there's a tiny piece of wire just here, which you probably can't see, but I'm just going to twist it. It's quite a tough one. There it goes. It's still springing, isn't it? There it is. So with that removed, the point can now slide freely. So now, when we change the point, you get a nice smooth motion and no short circuit. So all that remains is to obviously snip this wire to length, mark out the holes, drill and screw it into place firmly. Job done. Okay, all done. It's time for the big test. So in conclusion then, I should mention the price of these because they are quite dear. £21 each if you buy them singly, work out about £15 each if you buy 12 at a time. But so far I'm very impressed with the way they work. I'm very impressed with the frog polarity reliability. I will let you know how they go in terms of long-term sort of reliability. But yeah, when you consider that you don't have to buy a separate decoder board, that helps with the price a little bit. But so far I really like these, and I think I will be using them on the new layout. So thanks very much for watching. I will see you again soon.